Hi everyone, it's Sorkin. Today we have a problem when we are given a binary strings. For example, in this case, let's say that we are given 10, 0, 1, and so on. And also we are given two integers, m and n. So what we need to do is we need to return the size of the largest subset of string such that there are at most m zeros and n ones. So for example, let's say that here we are first one, right? So we are considering the first element. We have 1 zeros and 1 1. We are considering the next element. So now we have 4 zeros and the 2 ones. How about the next element, second element, right? From the second index from here. So can we consider this one? No, we cannot consider, because in this case, we are going, the number of the m's and n's will exceed. So we cannot consider this element. How about the next one? We can consider the third one, and we can consider the last element. So the subset, in this case, the largest subset with the utmost zeros and ones is this one. So 0, first, third, and the last index, and the size of it is 4, which we are returning here. Let's take this example and work on it. So we are going to solve this problem using dynamic programming bottom-up approach. So first, let's remind ourselves, what is dynamic programming bottom-up approach? The dynamic programming bottom-up approach is when we are taking a problem, we are dividing the two sub-problem. First, we are solving a sub-problem, then we are building up to our solution. So for example, in our case, let's go step by step. So what we do in the first step, we are taking each string. So let's say that we have only one string. Let's say that we have all in our input array, right? Let's imagine that we have only one input string, 1 and 0. So in the first iteration, what we do, for each string, we are counting zeros and ones. So we are counting zeros and ones. We have 1 0 and 1 1. In the next step, what we do, we are recalculating each subproblem considering the string in the reverse order. So what's that mean? So for example, in this case, we are creating two-dimensional array where we are storing our subproblem. So it's with the size of m plus 1 and the n plus 1. So n is equals to 4. N is equals to 3, so we have 0, 1, 3 for the n and the 0, 1, 3, 4 for the m. So which means that we are going to solve the subproblem. So for example, let's say when we have m is equals to 2 and n is equals to 2 and so on, and that would help us to build up to our solution. Let's go step by step. So what we do is, at each step, what we do, we are checking that for example, we are starting with the first one, right? Considering our first string, 1 and the 0. How we are going to consider that? So for this one, we said that we are going to do in reverse order. I will explain in a minute why we should go in reverse order. So we are going in reverse order, so which means that we are starting when our m is equals to 4 and n is equals to 3. So we are starting with for the m is equals to 4 and then n is equals to 3. So what we should do? We should do whatever the max value is here, or we can consider our string and take whatever the max value of this subproblem. What if we are considering our string? So which means that we need to subtract from our 4 and the 3, we need to subtract 0, how many zeros we have, and how many ones we have. So which means that the 4 minus 1 gives us 3, and the 3 minus 1 gives us 2. So which means that we are taking 3 and 2. So we are taking whatever the subproblem is here. So whatever the subproblem is solved here, and whatever we should have here, the max value, plus, since we are considering our string, plus our string. So we are checking that either we should take the 4 and 3, whichever is the max, right? Or this subproblem that we have already solved, right? We are already solved considering our string. That's why we are taking plus 1, because we are considering our string. So in our case, 4 and 3 gives us what? Gives us 1, right? Gives us 1. Gives us 0. 4 and 3 is 0 here, and 3 and 2 is also 0. So which means that the 0, we are comparing 0 plus 1, which is this is the maximum, right? So we are updating this value to 1. So we are going to do the same, exactly the same again. We are going to solve every subproblem, right? So we are going to solve for 4 and 3, and now we are solving when our m is equals to 4 and n is equals to 2, right? So we are solving now for this one. So again, we are checking that what is the max value if what is the max value is here, right? Already the value that we already have, or we are considering our string. If we are considering our string, so we are subtracting from I, which means that from 4 we are subtracting how many zeros we have. 1, and from the J we are subtracting how many ones we have, so which means that exactly the same, right? So we need to take this value 3 and the 2, so 3 and the 2, and we are comparing. Again, we will update this value to 1. So after we run the first iteration, right, for the 1 and the 0, so every cell here we will have the value we are going to update for every cell value to 1, because if we have only one string, let's imagine we have only one string, then in that case the value for if the m is equals to 1, n is equals to 1 would be 1. If the m is equals to 1, n is equals to 2, doesn't matter which combination of m, n we take. So our value, the subset that we have will always have the size of 1. Now let's take this first one. That was the first one, right? Now let's take the second one. We are taking now second one, and the second one, n is equals to the size we have 3 zeros, right? And we have how many ones? We have 1 ones. So we have 1 ones. We are now considering this scenario. Again, for this scenario, we are exactly doing the same that we have done earlier. So, but in this case, we can start only from here, right? We can start only from this position, because we have 3 zeros, which means that we are starting. We can start only from here when our n is equals to 3. We cannot consider these cases, right? When m is equals to 2, we can only start from here, and we need to have at least 3 zeros and 1 ones to start. So we are going to only reconsider for these scenarios, right? I hope it's clear, because when we are considering only for this scenario, if we have 3 zeros and 1 ones, 3 zeros and the 2 twos, 2 ones, and so on. So again, we are considering the same. We are starting from our top position, which is the 4 and 3, and we are moving backwards. So for example, in this case, we are taking the value. What is the value here? Value for the current value for 4, 3 is 1. But if we are subtracting, right? If we are considering, so value currently is 1. Currently is 1. And so we are considering this string, so which means that the plus 1, right? Plus 1 plus 1, and we are taking whatever the max value is if we consider this value, if we consider this string, right? So for example, in this case, if from 4 minus 3 gives us 1, which means that the m is equals to 1, and 4 minus 3 gives us 1, and 3 minus 2 gives us 2, which means that we are taking whatever the value is here, right? Whatever the value is here. Again, that's why we are calculating for every case. We are solving a subproblems, because the only way we can take the value here, we can consider this string, and because the only way we can do that, because we have earlier calculated what is the max value for this subproblem, for the subproblem of 1 and the 2, right? For the subproblem of 1 and 2. The value is here is 1, so 1 plus 1 or 1. So which one we are taking? This one is equals to 2, so which means that we are updating this value to 2. So we are updating this value to 2, and we are doing exactly the same for this scenario 2. For this scenario, we are going to have 2, and so on. So we are going to have 2. And then the next one, let's take the next string, right? So next string we are going to take 1. So now we are taking 1, and we are considering this string. Again, we have in this case only 1 0, only 1 1 and 0 zeros. So which means that that's why we also added additional zeros here. We have added additional zeros here because in this case we can start from m is equals to 1, which means that m is equals to 1, but the m can be 0. So m can be 0, which means that we need to consider this scenario, right? We need to consider this scenario. Again, we are starting from 4 to 3, right? Our value is currently is equals to 2 here. Our value is equals to currently is equals to 2, and we are moving backward. So we are considering 4 and 3, then we are considering 4 and 2, and so on. So we are we are taking the either current value again, 4 and 3, or we are considering this string. If we are considering this string, which means that our value becomes 4 minus 1, 4 minus 1, 3, 3 and 3. So whatever the max value is here, 3 and 3, right? So we have already solved this subproblem, right? We have already solved this subproblem, and the value is here equals to 2. So 2 or 2 plus 1 gives us 3. So which means that the max value here, we are updating that to 3. I hope now it's clear. So what we are doing here, right? So we are again considering each string, and we are considering each string, and we are recalculating every subproblem, moving backwards, right? Moving backwards. Why we are doing backwards? Why we are not moving, for example, starting from the first position? The reason is being that in that case, we may end up considering the same string twice. So for example, let's say that in the first scenario, right, in the first case, when we were just updating our first string, right, so this one. So in that case, let's say that we have updated here that to 1, but once we are advancing to this position, so we are taking the value from here, right? We need to take the value from here because we are comparing either maximum of the current position or considering the string, whatever the max subproblem that we had. So in this case, it will give us 2. It will give us a wrong result. So we will recalculate this. We will reuse the same value twice, right? It will give us a wrong result. So that's why we are moving in reverse order. So what's the first thing that we do here? The first thing that we do is we are creating two-dimensional array DP, and with the size of being n plus 1 and the n plus 1. And in the next step, what we do is we are creating a for loop, and in the for loop we are going over each string and counting the number of the zeros, how many zeros we have, and how many ones we have. In the next step, we are going over our two-dimensional array, and what we do is we are starting again from the we are starting from m and n, and we are working in the reverse order. So we are working until our m is equals to 0 and n is equals to 1. So what we do is at each step we are comparing. Either we are taking, as we have seen earlier, right? Either we are taking whatever the current value we have, or we are considering current string, and if we are considering, we are adding plus 1, right? And we are taking whatever the max value is after considering this current string. So for example, let's say that we have m is equals to 4 and n is equals to 3, right? So which means that either we are taking n is equals to 4 and m is equals to 3, that max, or we are considering the string, which means that we need to subtract from our I and the j, we need to subtract how many zeros we have and how many ones we have plus 1. So after subtracting it, we are taking the max value, and at the end we are just returning dp m and n. So what's the time and space complexity of this solution? So we have 3 for loops, and the first for loop is that the m, the size m to n, right? So the number of the ones. So for each case, we are going to reconsider. We are going to solve every subproblem, which means that we are going to go m and n, right? So for each subproblem with the size of m and n multiplied by l, which is the number of the string. So that's our time complexity. How about our space complexity? Space complexity is again determined by the size of two-dimensional array, which is m to n. Java solution is identical. So first thing that we do is we are creating two-dimensional array DP with the size of m plus 1 and m plus 1. In the next step, we are we are going over our strings and we are taking zeros. We are creating two variables, zeros and ones. So we are counting how many zeros we have and how many ones we have for this string. So in the next step, what we do, we are going over our two-dimensional array in reverse order, right? In reverse order. And for each cell, we are considering that either we are taking whatever the value is in that cell, right? Or we are considering our string. So how we are doing that? So we are subtracting from I zeros, and from j we are subtracting ones, which means that it will give us whatever the max value, right? Whatever the sub-problem that we have solved. We have solved already this sub-problem, right? So considering that plus one because we are considering our string, right? So max value of the sub-problem that we have solved plus considering our string. So whatever is the max, we are taking that, and at the end we are returning the m to n, which is our value. So the time and space complexity, the time complexity is, so m to n, we have 3 for loops multiplied by L, which is the size of our length of our input string, and the space complexity is determined by the dp two-dimensional array, which is m to n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.